Hey everyone, welcome back to AP Precalculus. This is lesson 3.1. Let's get right into it. All right, so here's the bell ringer for today. Pause the video if you haven't done so already because I'm about to go over the answer. So for number one, you throw a ball and its height increases then decreases. That's probably going to be related to number C, where the height of the ball goes up and then goes back down because of gravity. So 1 should be C here. Number two, you put a frozen pizza in the oven and the temperature increases quickly at first. This is probably going to be A for number two, and that's because the temperature goes up and then it starts to tail off and still increase, but at a much slower rate. And then three, you notice every day the temperature reaches its low at 4 a.m. and its peak at 4 p.m. So here we see we start low and then you go up where it reaches its peak. And then because every single day this happens, it's going to repeat. That is going to be 3b there. So that should be our bell ringer. And b is going to be a type of function that we will look at today, which is called a periodic function. And so a function is going to be periodic if the output values repeat itself over consecutive equal size intervals of the domain. So pretty much if a function has a pattern that continues forever, let's say we have that, right? And then you repeat that. This is going to be an example, if this was perfect, as a periodic function because it's never ending and it repeats itself over equal length intervals. So here are some examples of periodic functions. The first one, candy sales remain steady for the first 8 months. Then when around Halloween, it goes up and then kind of declines back by January and then continues this cycle every year. The next type of periodic function is the displacement of a buoy as it rises and falls with the ocean's wave. So it goes down, and then when the tide rises, it comes back up, and then goes back down again. That is another example. And then the third one is an electrocardiogram, or EKG, of your heartbeat, right? So your heartbeat will go bum bum, bum bum, and then like that. And this was one heartbeat, and this will repeat again over and over and over again. And so all three of these are examples of periodic functions. So what is a period? The period, which is your blank in your notes, of a periodic function is the smallest possible value for which basically a function will repeat itself. Or it's the length of the x values that it takes for the functions to complete one full cycle. So there's three things you need to know about a periodic function. It's the same pattern without any gaps in between, right? So you can't have, let's say this is your period, and then take a little gap there. That does not work. It's the same pattern with the same orientation. So let's say we have that as our periodic function. You cannot then all of a sudden flip it like that. That would not work. And then it's the same pattern without any vertical translation. Let's just say we have this as our periodic function. It all of a sudden can't jump up to that. So all three of those are examples of things that would be non-periodic. So example number one, the function f is periodic with a period of 4. And so as we see here, it takes 4 units for this cycle to kind of repeat itself. A portion of the graph is shown above. Draw 2 additional periods. So here, if we take a look, you go over 2 spaces and up 2 to get your first line segment there. So let's do that, over 2, up 2. So that should be our first line. And then you go across 1 like that, and then down 1 over 2, so like this. And so that is our first period, and then continuing this, it would look like that. So that would be our answer to example 1. Right? So one thing about periodic functions is horizontal translations actually make up periodic functions. This is basically if we have the same pattern, right? So let's say we just have an easy pattern like this. And let's say this period was 6, right? If we take this function and we move it 6 units left or 6 units right, what's it going to look like? It's going to appear as the exact same function because it's the same pattern every 6 units. And so, likewise, we can consider a periodic function as a horizontal translation of itself. And so take a look back at example 1. The period of that was 4. Let's say we take that graph, right? We copy and paste it 4 units to the left or even 4 units to the right. It's going to appear the exact same. And so this function will be the same or equal to that function shifted 4 units left or equal to that function shifted 4 units to the right. This is actually 4 units to the right, and this is 4 units to the left, though, so make sure that you're aware of your horizontal translations are inverse like that. All right, so for example 2, the graph of h is periodic with a period of 4. Values of h are shown at selected values of x. Fill in the following table to find the following values. And so here, if we know the period is 4, right, whatever our y value is when we have an x value of 2, which in this case is negative 2, will be the same for all x values that are 4 units away from 2. So whether it's 6, whether it is negative 2, right? It's always going to be 4 units away will have the same y value, which means 6 should be negative 2 there. Same thing with 3, 4, and 5 is if we have 4 units away from 3, which is at 7, that will have the same y value. And this pattern will continue, right? Negative 2, 0, 7, and then 6. And so that's going to be how we fill in the table. Now answering these questions, h of 2 from the table is just negative 2. That's just reading a table. H of 7 from what we filled in should be 0. So 0 is our answer there. And then h of 5 is going to be, first we want to find the inside. So h of 5 is 6. So this is really just h of 6, which is equal to negative 2. So that should be our answer for part C. Example 3, a portion of the graph of the periodic function of g is shown above. What is the least possible value for the period of g? So to find the period, I look at a key identifying feature. In this case, I see that sharp point right there. I see it again right here. And that is how long it takes for it to repeat itself. So I'm going to count the distance between them. So here, you're going from 1 to 6, so that's 5 units apart. So here, our least value of the period should be 5. Now, why does it say least possible value? Well, because you could make the case that the period could be 10, it could be 15, where it's just 2 of those patterns make up one period, but the least possible value is going to be 5, not any higher multiple of 5. All right, so now we want to find the following values. So I worked out the first one with you guys, is if we are looking for g of 14, right? Obviously that's not on the graph, but what we can look at is we can look at 5 units to maybe the left of g of 14. So this should be equal to g of 9, should also be equal to g of 4, should be equal to g of negative 1, right? When we know the period is 5. And so the main thing here is going to be able to look and find what is our number that we're given, which in this case is 14, and then you can add or subtract a nice multiple of the period. And by doing that, you're going to get the same y value. Now, you kind of have to just guesstimate or use a little bit of logical thinking to determine how many periods do you need to move up or down, but it should be pretty easy with these numbers. And so here, what I have is I did 2 periods of 5, which is 10 units, and I moved that many units to the left. So this should be the same value as g of 4, which in this case is 7. So 7 should be our answer there. Now let's work through the other two. We know the period is 5, right? So the g of 26 will have the same y value as g of 6 plus 20, which is 20 is 4 periods, so this should be equal to g of 6, which in this case, g of 6 is 5. So 5 should be our answer for part B. And then for part C, g of negative 17, I'm going to say this is g of negative 17 plus 20, right? You can also move in that direction to the right as well, which is g of 3, which here, that is also 7. So 7 should be your answer there. All right, so you should get 7, 5, and 7 for those three there. All right, so for example 4, the graph of h is periodic with a period of 5. Values of h are shown. Find the following values. All right, so let's work through these one by one. H of 4 from the table is just 3. So that's our answer for A. For number B, we're looking for h of 6. And so here, when we have an x value of 6, what is our corresponding y value? That's going to be the same as 1 because it's 5 units apart, which means we should have the same y value of -2. So -2 should be our answer for B. For C, we have h of 9. If we're looking for what is 9's y value, that's going to be the same as 4, which is 5 units apart. So this should be 3. So here, this can be replaced with the number 3. And so we're just finding now h of 3. So 3 is not our answer, but h of 3 is 0. So 0 should be our answer for C. And then for D, we have h of 1 plus 5k. Where k is an integer, right? So it's going to be a nice multiple of 5, which is essentially just saying what is h of 1? Because h of 1 will be the same as h of 6, which will be the same as h of 11, and so on and so forth. And so this should just be -2 as our answer for part D as well. All right, number 5. The graph of f is periodic with a domain of all real numbers. 2 full periods are shown. Find all the input values that yield an output value of 1. So here, if we take a look, we see an output value of 1 at 2. We also see an output value of 1 at 6. So here, how do we say x equals 2, x equals 6? But it's not just those two values, right? It's going to be within 2 or 6 plus or minus any number of the period. And so what is the period here? The period is going to be from 2 to 6, which is in this case 4. And so it's going to be x equals 2, x equals 6, x equals 10, x equals -2, -6. But how do we encompass all of those in one solution? And so very similar to example 4D, we're going to write x equals 2 plus the number of any multiple of the period, which is saying plus 4k, but then we have to specify. K can't be 2.5, right? Because then you get a weird number. It has to be a nice multiple of 4, which is tacked on to 2. So where k is an integer. And we need to specify that. So that is our answer there. All right, so now we're going to take a look at the third FRQ that you will come across in the AP Pre-Calc exam. And so you will see one of these questions on your next quiz, test, semester summative, and AP exam, guaranteed. The good thing is that for this portion, there's no actual math, there's not a lot of computation, right? And so you should be able to score these points pretty easily, but you do need some practice with it. And so it works like this. I'm going to give you a setup for a story problem. You're going to need to find coordinates that model that story problem. And typically it's going to be something going up, then down, then up, and so it's going to be periodic like that. It's really important that you set up these story problems correctly, because then you will have some actual pre-calculus questions that will ask you about this that we'll learn about how to answer later, and those will be incorrect if your setup is incorrect. So let's walk through an example and then I'll let you try one on your own. So here, let's take a look at example 6. The figure shows a large clock mounted to a vertical wall. So right here, sometimes they will give you a diagram, sometimes they may not though, so be careful of that. You won't always get a picture. The clock has an 8-inch long moving minute hand. So here, this is going to be 8 inches. The center of the clock is directly 120 inches above the floor. So let's mark that, 120. At time t equals 0, the minute hand is pointed directly up at 12. The next time the minute hand points up at 12 is at 60 minutes. As the minute hand moves, the distance between the minute hand and the floor is periodic and decreases then increases, right? So it starts up top and then goes a little bit closer and then comes back up and so on. And so that's going to be that periodic function that we looked at before. And now let's answer a few questions about this. So what we want to do is we want to answer question number A in your notes, which is basically asking you to find 5 coordinates that model this situation. So 1, 2, here there'll be a midline, 3, 4, and 5. So to find 5 coordinates, there's technically multiple different answers that you can have, but typically you'll get the same answer. And so these are the steps that I would take to start this question. Step number 1 is label your axis. This is given by the final statement in yellow. The x-axis will typically be time, and then the y-axis will be height or distance from a point. So taking a look here, this is our axis, right? And so when we have our graph here, I would label that this is time in minutes. And then I would even draw a y-axis just to start with. And then this is going to be distance from floor. In inches. All right. The next part is number 2. Label your diagram if you're given one. You may not always be given a diagram, and so what I said before, but I would label 2 things. I would label the center of the clock to the floor and how long the minute hand is how long is the minute hand in the problem, and so that's given here. And so we know the clock has an 8-inch long moving minute hand, so I would label this as 8 inches, and then from this to the floor would be 120 inches. All right. Those are the 2 things that I would label. You could also go more in depth and label that the total distance right now is 128 inches, and then if this is 8 inches this way, right? The shortest distance it's going to be from the floor is 120 minus 8, so 112 inches there. The third step is find your period. This is how long does it take for one cycle to be completed. If we take a look here, it is given in purple. And so here it says at time t equals 0 minutes, the minute hand is pointed up at 12. So this is at time t equals 0. It's at 12. And then the next time the minute hand is pointed at 12 is at t equals 60 minutes. So this is our period from 60 to 0 is 60 minutes is equal to our period. So that's the important thing you want to recognize is what is your period. It could be 60, your period could be 1/3, it could be 7. On last year's AP free response question, the period was actually 1/200. So be cautious because you could have weird periods as you get to harder of problems like these. All right, so now we will do step 4, 5, and 6 kind of in one go. We first want to find our min and our max. We kind of did this already, but now we want to label it. And then you want to find your midline by knowing that G will be exactly halfway in between your min and your max. And then finally, given in green, we want to find our starting point. So I will repeat those as we actually work through this. So if we had what we drew before, right, we knew this was 8. We knew the distance from the middle of the floor, or the middle of the clock to the floor is 120. And then obviously the shortest distance it can be, if this was also 8, this would be 112. And so here you're going to have a diagram like this. And so if I draw it out, and then you had 5 points, right? You have F, G, J, K, and I think P. Yeah. And so what is our maximum height from the floor? That's going to be 128, which is that total right there. And so let me erase that so we can label our diagram. This right here, I would write the number 128 right there. What is the closest we can get to the floor? That's going to be 112. So I would write that and label our diagram. And then smack dab in the middle is going to be between 128 and 112. you can always just find the average of those two numbers by summing them and then dividing them by 2. Or in this case, right, the average is going to be when it's in the middle, so that's going to be at 120. So now that we have those 3 lines labeled, that takes care of 4 and 5 in terms of our steps. And so number 6 is find your starting point. And so this is given to us in green. At time t equals 0 minutes, the minute hand is pointed directly up at the 12. And so when we do this, we want to see if our starting point is going to be our minimum, is it going to be a maximum, is it going to be, maybe one of those middle points on the midline. And so if the minute hand is pointed up directly at 12, right? Think about it. How far away is the end point of our minute hand to the floor? That's going to be at the maximum value. So I would label this as 0 in terms of our x values, right? So if you were labeling your x values, this would be 0. And then because we also know the period is 60, this should be 60 there for P. And now the final 2 steps. Now that we have our y values completed, we can find our x values by dividing your period into 4 and then assigning each point the correct y value based on the period and the starting point. We can use fractions as needed, and then pay attention to how the graph moves. This may alter things and is given to us in gray. So right here, we just want to take note that the minute hand moves. The distance between the endpoint and the minute hand will start by decreasing and then back to increasing, and then it will do this again and again. So it's going to start at the maximum and go down, which we kind of already knew. It just reconfirmed it to us. So let's work through this whole thing together and actually answer part A, right? So step number 1, I'm going to run through the steps again. Step number 1, label your axis. This is given by the statement in yellow. And so here, my axis is going to be time in minutes. And then my y-axis here, and I'm just going to draw this, is going to be distance from floor in inches. All right. Number 2, label your diagram if you're given one. We kind of did that already, so I'm going to skip that step. Step number 3, find your period. And so this is how long does it take for one cycle to be completed. That was 60 minutes, so I'm just going to label that 60 there. Step number 4, find your min and your max and label them on your y-axis. So we learned that our min was 112 and our max was 128. Step number 5, find your midline by basically summing those up and then dividing it by 2. Or if you looked at the story problem, right, we found our midline was 120. Step number 6, find your starting point. This is given to us in green. And so this would be at time t equals 0 is where we're starting because it's pointed directly up at the 12, which is a maximum. Let's also, I forgot to do this, fill in our y values now that we know our y values. So those will both be 128. These two will both be 120. And then this one will be 112. All right, so now we have all our y values filled in. We also have our starting point filled in, so that's great. And now we can also fill in our period. So we know this should be 60 units away horizontally, so that should be 60. And then step 7, this is very important. Now that we have our y values completed, this is split into 4 equal sections, right? This is the same length as this unit, which is the same length as that part, which is that part. So if we want to find the x coordinates of the middle 3 points, what we can do is we can chop up 60 into equal fourths. So what's 60 divided by 4? That should be 15, which means this should be 15 units apart. 15, 15, and 15 to add up to 60. So 0 plus 15 is going to go in there. That plus another 15 should be 30 in here. Plus another 15 is 45. And then 60 there. So let me erase some of this work that we don't need. And so that is how we're going to get our other x coordinates, is taking your period, dividing it by 4, and then allocating it correctly there. Right? And that's our answer. We have our 5 points. This is going to be 2 points on the AP exam. It'll be worth a lot more on my test, but it should be 2 big points. And so as long as you're able to interpret that story problem, you can get these coordinates pretty easy. All right, so working through example 7, we have a very similar setup. Let me draw the photo on the side as well. So you have this clock like this. And so the figure shows a large clock mounted to a vertical wall. This time the clock has a 10-inch moving minute hand. The center of the clock is 180 inches above the floor. At time t equals 0, the minute hand is pointed directly up at the 12. However, and then this is the key, the clock is not working properly, and the minute hand is moving 3 times as fast as it should. So the next time the minute hand is pointed directly up at the 12 is at t equals 20 minutes. As the minute hand moves, the end point of the minute hand to the floor decreases then increases. And so let's work through our 7 steps and label what we need to label. So first, we're going to label the x-axis, and this is going to be time t in minutes. And then our y-axis here, and you don't need to do this step every time, is going to be distance from the floor. In inches. All right. And so now what we want to do, step number 2, is going to be to label our diagram, which we kind of have here, but we then know this is 10 extra inches, and then this is 10 inches as well when it's this direction, which means that the lowest it can be is 170, and the highest it can be is going to be 190 inches. So let's label then our diagram, or our chart here. So we know 170 will be the minimum, 190 will be the maximum, and then smack dab in the middle will be 180. So here I'm going to label our y coordinates as well now that we know those. 180, 180, and then 170 there. That's good. Now let's find our period. And so we know we start at t equals 0, and then the next time it's pointed directly up at the 12 is not at 60, but now at 20 minutes. And so here our period is 20, so I'm just going to make a note of that. Period equals 20. And then let's find our starting point. And that's just going to be at t equals 0. The minute hand is pointed up at the 12. And so here, this is going to be our starting point here. So 0, 190. And then, because the period's 20, this should be 20 here, right? It should be 20 for one full cycle or rotation. And now what we want to do is we want to chop this up into 4. So 20 divided by 4 is 5. So from F to G, this should be 5 units. From G to J, it should be 5 more, so 10. J to K should be 15. And then K to P should be 5 units apart, so at 20. And that's our answer. Those are everything that we need labeled, and that would get us full credit on an AP exam there. Now there's 2 more questions that you're going to have to answer as well. And so taking a look here, this is the same coordinates that we have for part I. From on the interval from T1 to T2, which of the following is true? Where T1 is G and then T2 is J. So the question will always be worded like this, and we've done these before. G to J is this portion right here. And so whether this is positive, negative, increasing, decreasing, we want to know. And so for part 1, taking a look, our y values are all positive. So it should be a positive function. So we can eliminate C and D. And then obviously this function is going down, so it's decreasing. So B should be the correct answer there. Right, and then part 2, describe the concavity of the graph of H and determine whether the rate of change of H is increasing or decreasing. So here we want to use fully answer the question. So I would say H is concave. And if you take a look, that portion is a part of an upwards U shape, so concave up. And I would say the rate of change of H is, and now we just want to say increasing or decreasing. And anything that's concave up will have a rate of change that's increasing. So increasing should be our answer there. So you do need to say both of these things, but as long as you do, you'll get full credit. Right, so this is just a general guideline for that second portion, which is, remember for the first one, the question is asking about the graph of h, nothing about the rate of change yet, or concavity. So the first part will just be whether it's positive or negative, and then increasing or decreasing. The second part will be asking only about concavity. Positive and negative is just whether it has positive or negative y coordinates. It will only be one or the other. So it could be from, let's say, 0 to -3, right? Those are going to be a negative. Let's say it's from, we'll go, let's say, 7 to 10. That's going to be a positive one. And so that's how you answer that. And then increasing versus decreasing, whether it's just going up or down. For part B2, you will either say one of two things. H is concave up, so the rate of change of H is increasing, or it's concave down, so the rate of change is decreasing. You'll never mix any of those. It's either going to be one or the other. And then really, to determine whether it's concave up or down, just see if it's part of that upwards or downwards U shape. All right? So just make sure you don't get these questions mixed up. These are pretty easy points to get. And a lot of students get these right on the AP exam because this question verbatim will show up on your next quiz, test, semester summative, and AP exam. All right, example number 8. The figure shows a merry-go-round on a level ground with a fence to its right. The merry-go-round rotates in a counterclockwise direction and makes one rotation every 7 seconds. So this right here is going to be our period. So 1 period is equal to 7 seconds. I'm just going to label that right now. Point B is on the edge of the merry-go-round and is located at the closest part of the merry-go-round from the fence. So even though point B is there, technically it's going to start right here at time t equals 0. So I'm going to label that. Sometimes the diagrams can be a little misleading. That's why I added in this is not aligned with the picture. All right. And then point B is 4 feet from the center of the merry-go-round. So here, if we kind of draw this even just a little bit more 2D, point B is going to be right here. And then this is 4 feet from the center of the merry-go-round. The center of the merry-go-round, however, is 10 feet from the wall. So this is 10. As the merry-go-round rotates at a constant speed, the distance between B and the fence periodically decreases then increases. And so let's take a look here, right? What is our x value? That is going to be time in seconds, not minutes this time. And then what is our y value? That's going to be distance from the fence. And this is because we're given here models the distance between point B and the fence in a function of seconds. All right. Now what we want to do is we want to find our maximum and our minimums after we kind of label our diagram. So here, think about it, right? What is the closest that point B can be to our fence? And that's going to be, if you know that this fold length is 10, right? And this part is 4, then the closest it can be is going to be 6. And what's the furthest it can be? That's going to be when it is fully away right here. And that's going to be when it's 4 plus 10, so 14 feet from the fence. So our maximum here should be 14. Our minimum should be 6. And our midline should be 10. Now that we know that, let's label our y coordinates there. And then I'm actually going to, you'll see why later, just move those to the other side, but it's still the exact same thing, right? Now let's take a look at our starting point. We know our period is 7 seconds, but where are we starting at? We're starting at point B, which is at the closest part to the fence. Is that going to be, and so we want to ask ourselves, is at point B when it's the closest possible to the fence? In terms of our y value, which is distance from the fence, is this going to be a maximum or a minimum? And it should be a minimum. And the reason for that is because it's going to be the closest it can be to the fence. When it's at a minimum, we're actually going to want to do something a little bit different. You are going to want to extend this graph out like so, and start time t equals 0 right here. That way, all 5 of these points will have a positive time value, right? And so you're not going to be worried about that. We also know our period is 7 seconds. So here, from that point to j, this should be 7. Now, how do we figure out the other coordinates, the other x coordinates, now that we know the period is 7? And this is going to be a trick that you will need to use, is we're going to take 7 and multiply it by 4 over 4, which is multiplying it by 1. This will get us 28 over 4, all right? And that is going to be 1 full period. And so here, what I'm going to do is I'm going to rewrite this as 28 over 4, and then divide this by, what's 28 divided by 4? That's 7 over 4. That's going to be our x value here. 7 over 4, 14 over 4, 21 over 4, 28 over 4. And 28 over 4 is 7, so it's still the same thing, and we don't actually need to simplify our fractions. Finding the other two x values, we're going to keep adding 7. So 35 over 4, and then 42 over 4, right? So let's fill in our x values here. So this is 14 over 4, 21 over 4, 28 over 4, 35 over 4, and then finally 42 over 4. And those should be our answer to part A.